you may have experienced this. You can follow an AI explanation but cannot rebuild the logic in your own words. This lesson solves one concrete problem, from getting an answer to truly understanding. By the end, you should be able to prove understanding through recall, examples, counterexamples, and boundaries, and leave evidence. Understanding is not a feeling you receive from a clear explanation. It is a capability you can demonstrate after the explanation is gone. In this lesson, we will slow down the moment after an answer arrives. We will use one ordinary learning problem and test it 4 different ways. The test is deliberately practical. If the learner can produce evidence, the learning is real. If not, the answer was only borrowed. Separate the 2 states. The old state is you can follow an AI explanation but cannot rebuild the logic in your own words. The target is prove understanding through recall, examples, counterexamples, and boundaries. The difference can be checked through behavior and results. Imagine a learner trying to understand a pricing model. The AI explanation is fluent, the diagram looks convincing, and the learner can nod along. But when one assumption changes, the learner cannot say what should change in the result. That is the gap between recognition and understanding. Recognition asks, have I seen this before? Understanding asks, can I rebuild the reasoning when the surface details change? Consider a real case. The learner wants to prove understanding through recall, examples, counterexamples, and boundaries. But you can follow an AI explanation but cannot rebuild the logic in your own words. The issue is not effort. The process is not producing evidence. Before using any tool, write the problem in 1 sentence and name the result you need to produce. Then, record what you currently believe, even if it is incomplete. This gives you a baseline. Without a baseline, a polished AI answer can hide the exact misconception you needed to find. The goal is not to avoid AI. The goal is to make your starting point visible enough to compare later. The method has 4 moves. Explain in your own words, create an example, find a counterexample, explain the boundary. They form one chain. Each move gives the next move useful information. The 4 moves are a sequence rather than 4 unrelated study tips. Your own explanation exposes missing links. An example tests whether the idea can touch a concrete case. A counterexample tests whether you can notice a tempting failure. A boundary states when the rule stops working. Together, they turn a vague feeling of understanding into a small, inspectable proof. Step 1. Explain in your own words. Turn explain in your own words into a visible action with a condition and a result you can review. Ask what you do, under which conditions, and what result you can observe. Start by explaining the idea without looking at the answer. Use ordinary words and 1 sentence for the mechanism. Then add the condition. When would you use it? And what would you observe if it worked? A useful explanation contains an action, a condition, and an expected result. If you need to quote the AI wording, stop and mark that phrase as a gap rather than pretending it is yours. Return to the case. Use AI to clarify standards or find omissions, but keep the key judgment human. The next move should use evidence, not an impression. For the pricing case, an acceptable explanation might be, I compare the change in revenue with the change in the variable cost while keeping the time period and volume consistent. That sentence is not perfect, but it reveals the variables that matter. A weak explanation would simply repeat, use the model to optimize pricing. It sounds professional while giving no observable action and no way to check the result. Step 2. Create an example. Turn create an example into a visible action with a condition and a result you can review. Ask what you do, under which conditions, and what result you can observe. Next, create a small example that you can calculate or inspect by hand. Keep it smaller than the original problem. Change only 1 condition at a time and predict the direction of the result before asking AI to check it. Examples are useful because they force the abstract words to make a commitment. If the commitment is wrong, you have found a learning opportunity, not a reason to hide the mistake. Return to the case. Use AI to clarify standards or find omissions, but keep the key judgment human. The next move should use evidence, not an impression. In our case, choose 3 products with different costs and prices. Predict which product has the highest contribution under the stated rule. Then change the sales volume while leaving the margin unchanged. If your conclusion changes, explain why. An example is not decoration for a lesson. It is a controlled experiment. Keep the input, your prediction, the observed result, and the correction in one short note. Step 3. Find a counterexample. Turn find a counterexample into a visible action with a condition and a result you can review. Ask what you do, under which conditions, and what result you can observe. A counterexample asks where the rule could mislead you. Start with the conclusion you just made and search for the smallest situation in which it fails. Do not search for a bizarre edge case first. Look for a common condition that the original explanation quietly assumed away. This is where AI can help as a critic. Ask it to propose a plausible case that would break your reasoning, but judge the case yourself. Return to the case. Use AI to clarify standards or find omissions, but keep the key judgment human. The next move should use evidence, not an impression. Suppose the highest contribution product also has a supply limit, a return rate, or a contractual price floor. The original ranking may no longer determine the best decision. That does not make the method useless. It tells you which condition was missing. Write the counterexample in the form, "The rule works when, but it fails or needs adjustment when." This sentence converts an error into a reusable warning. Step 4. Explain the boundary. Turn explain the boundary into a visible action with a condition and a result you can review. Ask what you do, under which conditions, and what result you can observe. Finally, explain the boundary. A boundary is not a disclaimer added at the end. It is part of the model. State the assumptions, the scale, the time window, and the decision the method is allowed to support. If the evidence is too weak, say what additional observation would be needed. A learner who can name the boundary is less likely to apply a correct idea in the wrong situation. Return to the case. Use AI to clarify standards or find omissions, but keep the key judgment human. The next move should use evidence, not an impression. For the pricing example, the method may support a short-term comparison under stable costs and reliable volume estimates. It may not support a long-term investment decision, a forecast under a supply shock, or a comparison across different time windows without more data. Ask AI to challenge your boundary, then revise it in your own words. The revision is evidence that the method is becoming yours. Choose a real problem. Do not open another tutorial. Start with explain in your own words. You have 5 quiet seconds to write the first move. Now combine the 4 moves into one practice loop. Choose a real question from your work or study. Spend 3 minutes writing your explanation before opening AI. Build a tiny example, then deliberately change one condition to create a counterexample. End by writing the boundary and one observation that would tell you whether the method is safe to use. Save the page. The page is more valuable than a feeling of fluency. You have learned this lesson when you can explain the first move, complete the middle moves without copying, and use the final move to check the result. Use AI selectively during the loop. It can ask a question, generate a contrasting example, or point to an assumption you missed. Ask it not to rewrite your explanation till after you have committed to one. If AI supplies the whole chain too early, you lose the evidence of your own reasoning. The right order is learner attempt, targeted feedback, learner revision, and an independent check. Remember, prove understanding through recall, examples, counterexamples, and boundaries. Complete one real practice and save the evidence. Next, we will study how do you define a verifiable learning goal. To accept the lesson, do not grade yourself by confidence. Use 4 observable standards. Explain the idea without copying. Create an example that behaves as predicted. Identify a credible counterexample. And state a boundary that changes your next action. If one standard fails, return only to that move. Focused repair is faster and more honest than restarting another complete tutorial.